So this is what it looks like to look through a binocular night vision device, and this is what it looks like to look through a pano. When Nocturn Industries dropped this image on social media a few years back, it took the night vision world by storm. After all, like many ideas that seem far too obvious for their time, adding articulation to a panoramic goggle seems like a huge upgrade over the existing fixed bridge designs. So if you follow night vision news, you'll know the story behind the development of the Nocturn Industries Chimera was a bit tumultuous because you have to improve on such a tried, true, and tested design. But I do believe the Chimera improves on the existing pano concept in a lot of really interesting ways that go beyond just the obvious articulation itself. So before we go over the in-depth comparison, I do have to be honest with you guys. This is not a L3 GPNVG, this is an Argus APNVG. So the reason for that is twofold. First off, this is a lot easier to get in the international market. Of course, we're in Canada here. And secondly, this is more apples to apples because this is a user configurable system versus the L3, which is a factory built system. If you get a GPNVG from L3, it's going to have this exorbitant price tag. It will come with L3 tubes, and it's going to be epoxied and all sealed, and it can't be repaired or replaced except by L3 themselves or a licensed L3 technician. The Argus and the Chimera, on the other hand, if you go to any builder that's capable, they should be able to build it. You can put whatever intensifiers you wanted it all the way to L3, Elbit, 4G high gain, crazy, 2500 plus FOM. And if you really wanted to, you can even put things like NVTs in here, although I'm not sure why. So full disclosure, just an apples to apples comparison. We can look at the features of this goggle because they're the exact same and compare it to this one as a representative for a legacy pano versus a modern articulating one. So first off, we're going to start off with the bridge of the goggles. The Chimera bridge is obviously an articulating bridge versus the GPNVG or APNVG bridge, which is going to be a fixed bridge. I cannot fold this unless I wanted to break it. The advantages of the articulating bridge are just like the advantages that you have in an articulating binocular goggle setup. The first benefit being stowage. So when you articulate the goggle and you roll it up, it feels really nice against your head. The best analogy that I can think of is if you're holding a 5-pound weight in front of you, it's going to feel a lot heavier if you hold it all the way out here versus if you hold it close to your body. And bringing that weight closer to your head, neck, and spine really reduces your neck strain. And there's a lot of research that's coming out currently going over long-term neck strain and injuries with soldiers wearing heavy ballistic helmets and night vision on their head. From an operational standpoint, from a long-term standpoint, reducing that weight might actually pay you dividends in your health in the future. Secondly, articulation allows you to use this goggle in really low ceiling environments. So let's say you're in a car, you're somewhere that's like in a crawl space or something like that. Being able to fold the goggle allows the goggle to be a lot more low profile versus wearing a full panoramic folded up on your head like this. And lastly, articulation allows you to use prism and thermal optics that you may have on your rifle setup without having to lose all of your night vision capabilities. So you can have one tube over here, night vision on, looking at what you need to look at, and then you can look down your rifle, weapon sight, handheld thermal with the other eye without losing your night vision. Nocturn has a few variations of this bridge. One of them is external power only. We're rocking what's called the SOCOM bridge here that has a dual fuel capability, which means that it can take external power via a double odd LEMO port, and it also takes internal onboard power via a CR123. So this cap comes off. It has a CR123 inside. You put it in positive side first, negative facing out, and then you screw the cap on. Threads are nice and coarse too, so you don't have to screw it on for a million years. And now your goggle functions pretty much like every other Bino on the market. You can turn it on and off without having to connect it to an external battery pack. The button is very, very positive. It feels very similar to a Surefire rear clicky tail cap. It's also guarded to prevent against any accidental activations. Now, the button over here is a lot more positive, in my opinion, than the existing GPNVG or Argus button. This one feels more of like a mouse click, and this one feels like that clicky tail cap. You're doing stuff and you want that tactility. The tactility on the Chimera is going to be a huge improvement over the existing GPNVG design. Now moving back to the onboard power. This guy is going to be external power only, which means that you're going to need a battery pack and you're going to need to plug in a Fisher cable. On a battery pack, about 40 hours. But again, you're going to need that battery pack. It does come with one, but you can't run it without. Whereas this guy, dual fuel capability with the SOCOM bridge. The battery gives you one night basically of operation, or you can also use an external pack. Any standard battery pack will work fine as long as you have the right cable. In this case, it's going to be a double aught LEMO cable. And if I open up the goggle and show you the bottom, the power port is right at the bottom over here. This actually can be exchanged with some optional add-ons. So if you already have an existing Fisher cable battery setup, you can exchange that for a Fisher cable. If you want to actually run it slick on the bottom and run it with internal power only, you can do that as well. You just need to buy the swappable base plates for it. So you're going to index the white dot to the white dot over here. And there you go. Now your goggle is running on external power. What's really cool about this goggle is, I'm going to turn it on so you can see, is it runs fine on external power, but it also has a backup. So what it will do is it'll run on the external batteries first, and then it will go to the internal battery. If this cable becomes damaged, the battery pack runs out of power, I'm going to disconnect it right here. Goggle is still on. You don't lose your night vision. Works perfectly fine because it uses the internal battery. Now, one thing that you have to keep in mind is that it needs the internal battery for the goggle to complete its circuit. I don't really see that as a downside. It's just nice to have a backup in case things fail in the field. Now, moving to the top of the bridge, very, very simple. You got your two little lanyard holds over here that you can tension the goggle on, which is going to be important for a goggle of this cost. At the end, you have your IPD adjustment over here. What I do like about the Nocturn goggle is the IPD is very, very granular, and that's super important. Parallax is really important for a panoramic goggle. You do want to get the center two tubes to overlap in your vision really, really nice, so you get that cool sideways snowman effect. And making it granular allows you to really fine-tune it for a wide variety of faces and eyes out there. Going back to the bottom, these goggles also feature a Hall effect magnetic cutoff switch. What that means is that if your goggle is on, like so, you simply rotate the pod up, it'll cut off automatically, and you do the same thing with the other pod. So it just preserves the life of your tubes and also reduces the amount of backsplash to your helmet, so you have a lower signature at night. Now on the rear, you're going to have the pod tensioning arms, and these are actually made of steel versus aluminum that the rest of the bridge is made of. What's really cool about these pod tensioning arms is that they actually have detents on them. So if I were to fold this near my microphone, you can probably hear it. That's going to be a ball detent that clicks and allows you to have a really, really secure articulated position on this nod. Because these pods are going to be a lot heavier than binocular pods, you do want that extra security so that they don't fall down on you during high-speed operations. On the rear, you're going to have some small torque screws that you can adjust to adjust the tension of the articulation. We do set these out of factory for you, so that way they have what we consider to be the perfect pod tension. And one last feature on the bottom, you'll notice there's two little set screws over here. These are so that you can make sure that the goggle is sitting parallel when it's articulated down. That's going to be really important for collimation, which we'll get over later. That also should be set properly out of the factory, but for some reason, if the material starts to wear or you find that it's not sitting parallel, you can adjust those to your liking. And that about covers the bridge. But there's more to the Chimera than just the bridge. So on the front of this device, you're going to notice this is where all the magic of the Chimera happens in terms of its optical assembly. If you've assembled nods before, you know that the Argus is not impossible to build, but it's not exactly the most pleasant nod to build. The Chimera, on the other hand, is pretty easy to build. So if you're a professional unit out there, that might make actually a huge difference in terms of turnaround time and repairability. The front of this nod uses standard PVS 14 lenses. It's going to come with RPO NVDN or RPO 4.0 lenses as of now. These lenses have great optical performance. We're going to go over that in a bit, but if you do want to see an in-depth performance overview, you can check out my RPO overview that I did a while back. Pretty much the same points as there. What these lenses do, other than give you great performance, is they allow you to use a lot of standard accessories. If you look at the GPNVG or the Argus goggle over here, these guys use 31 lenses. And while there are accessories for 31 based lenses, they tend to be a lot more limited, and they also tend to be more expensive. If you guys have interchangeability of parts between your panos and, let's say, guys on your unit using binos, if you need to switch lens protectors, all that stuff, that just makes things a lot easier because I can screw a chat on this guy over here, no problem, onto the standard bino. And then for this pano, you can also do the same thing to all four lenses. You can screw any variety of accessories on it. So you have an iris here for close focus, controlling your depth of field. The Chimera also uses very standard locking rings. So the front locking ring over here is also compatible with accessories such as this clip-on thermal imager, which I'm going to put on over here. Screw that in. And now you have clip-on thermal image capability with your Chimera. It also looks really cool because the tan of the Jerry C Pro really closely matches the tan of the tan Chimera. Whereas the GPNVG, there does exist a bracket for this guy to accommodate this, but again, another additional cost, especially at scale if you're looking at outfitting a bunch of your guys with it. And because it's a separate piece, you're going to have to buy that separately. Whereas the standard bracket that actually comes with the Cody out of box will fit on this no problem. Although we, of course, prefer to use our upgraded one. Moving on from the Infinity collar, you're going to move on to the collimation assembly for the Chimera. And the collimation assembly is one of the biggest improvements to the Chimera over the existing GPNVG 18. So collimation. On a night vision housing, collimation is an important aspect to get a usable image. And what this means is you're basically either rotating or shifting the lenses to ensure that they're all rendering the same thing, so you don't get any shear or any headaches or anything like that. Now on a Bino, poor collimation is unpleasant, but on a panoramic device, poor collimation creates a lot of shear and basically makes your image unusable. So let's start with the Argus goggle. These goggles collimate in the front by using a star-shaped pattern insert that the lens rotates on. The star shape is a little bit off axis, and as you rotate the lenses and click it into each vertex of the star, the image will shift slightly. And ideally, you will get all the images from each of the 4 tubes to align and create a perfect, seamless image. There is, however, 2 problems with this. First off, it involves taking the night vision device apart and putting it back together, which is quite tedious and can introduce foreign debris. The other thing is, there is a fixed number of angles to put the lenses on. If you rotate the lenses through all these angles and the image still doesn't align, you're kind of out of luck. You will have to resort to more drastic measures, such as shimming the tubes or picking new intensifiers. The Chimera, on the other hand, makes this process far simpler. If you undo these 3 screws at the front, there is an O-ring gasket to prevent any debris from getting in, and you simply just need to undo them slightly, and the front of the lens sort of tessellates at an infinite angle. So that way you can align the image perfectly with each of the 4 intensifier tubes without having to take the goggle completely apart. What this means for you is that you have a much more unified collimated image, and you can do this at scale far easier without debris incursion. Going to the bottom of the pod, here's where you're going to have your purge screws. We've tested this guy, holds vacuum seal and purges no problem. Should be good to use in any sort of austere conditions, including water, rain, snow, all that stuff. In terms of materials for this housing, it's an overall upgrade from the GPNVG/APNVG polymer system. The pods will come in 3 distinct versions. The first version of the Chimera will come with machined magnesium pods. Down the line, Nocturn plans to release a ruggedized and lightweight version of the Chimera in line with their other goggles. The ruggedized Chimera will come with 70-75 aluminum pods, and the lightweight version of the Chimera will come with fiber-reinforced nylon pods similar to the materials used in the existing Katana, Raptor, and Manticore systems. Now moving on to the top, you're going to see how the pod attaches. The attachment method for the Chimera is also going to be a lot more durable than the existing Panos out there. These Panos attach via a little dovetail on the pod that has power contacts, and then it clips on, and it's held on really only with this one tiny screw. The reason you might see a lot of SF guys using this Pano with like an elastic band around the pods like so is because that part has been known to fail. Versus the Chimera, it has a very, very robust arm made of metal, and it's attached on via 4 screws to the pod. Overall, far more robust design, improves on one of the structural weaknesses of the existing panoramic design, and because it articulates, if this takes any shock, what's nice is it can roll up, and that motion actually reduces the amount of shock that your tubes take. Now moving on to the rear, you're going to see that the Chimera has a way, way bigger optical window than the existing goggle, the GPNVG. And the way they did this is actually fused RPO NVDN or RPO 4.0 glass, but overall, much more comfortable to use just because you have much larger window you're looking through. You're going to also notice on the rear, they have these 2 little nubs on the bottom and this one larger one on the top. That's how you're going to attach your rear lens accessories for the Chimera. Now, as of the making of this video, those don't exist yet, but Nocturn and us are working on a lot of accessories, so stay tuned for those. On the GPNVG, this does come with a -0.5 diopter clip-on. It works fine, but I'm going to tell you right now that it's really hard to get these off without really long nails or a screwdriver. Whereas While there's no accessories that out of the box for this yet, we did make some camera adapters, which I'm going to get into later. And these are really easy to clip on and off. In fact, I can just do that right now. Clips on, super secure, can hold it right there, and comes off also really easily as well. So I can imagine that the future accessories for the Chimera are also going to be secure, but also easy to don and doff. So we worked hard 3D printing, designing a few different accessories for both these goggles. One of them is going to be these guys over here. These attach onto a DJI Osmo Action 5. These are fantastic little action cameras, and the reason we're using these guys is so we can put two of them side by side like that, and then stitch the images together to get you a proper panoramic view in 4K. However, because these guys record so wide, there are some effects of the pano that are a lot more exaggerated than they would be with the human eye, such as the seam in the middle of the fused glass elements. The Chimera actually does not really even have one when you use them, whereas the Argus has a very, very minimal one. In order to get that seamless view for certain tests, we're actually going to be using our standard Sony Alpha cameras with a 24mm lens and one of these adapters over here. Now keep in mind, because these cameras are rather large, because their sensors are so big, it's not really possible to record with two of these cameras on the same device. It's actually very, very difficult to record through panoramic devices. These devices are designed for the human eye, and the camera can't really capture all its magic. So you're going to have to kind of do a little bit of imagination with your brain to get you a better representation of the optical qualities of the lenses, and then we're going to use the action cameras to show you what you would really see. First, we're going to start with our lab tests. Most of these tests are conducted using our Sony a7S III rig with the same camera settings we use in our standard testing methodology that you've seen in our other videos. If you want the exact settings, they're going to be listed in the description below. For this comparison, we're using clean Photonis 4G tubes. They've been matched as closely as possible in spec to minimize variables and to provide the most accurate comparison between the goggles. The reason why I'm not swapping the tubes between the goggles is because these panos are a bit more difficult to build than standard goggles, and I believe swapping them and swapping them back for all these tests is actually going to introduce more variables than using two very similarly matched tubes. We'll first start off with the Hoffman resolution test. If you've watched our previous videos, you'll recognize this test is essentially a Snellen eye chart for your night vision. The Hoffman puts out a granular and adjustable level of illumination that's very precise and will evaluate how well the tubes and optics resolve the line pairs as the light levels go down. As the light levels go down, the image will get noisier and the finer line pairs will get harder and harder to resolve. Looking at the results, both devices clearly have excellent glass. However, to my eyes, the Chimera appears slightly sharper, with better contrast and clearer separation between light and dark elements of the chart, with sharper line pairs overall. This is especially noticeable in group 5 of the line chart, where the physical number 5 that you're seeing on the line chart is slightly sharper on the Chimera versus the APNVG. And of course, in all of our tests, this is the same. As light levels go down, it's going to be harder to see. And when you get down to these extreme light levels, no matter what tube and glass you're going to be using, you're going to need supplemental illumination. So don't forget that as part of your entire setup. As an extension of the Hoffman resolution test, I wanted to do this test to show the finer differences between the night vision devices. So I'm not using my A7S III, I'm using the photography version of that camera, which is going to be an A7 IV, which captures a 33 megapixel image, so very, very high resolution. This test confirms what we saw earlier. I focused both devices as carefully as I could while keeping the camera settings locked, and I took multiple images and selected the sharpest examples for comparison. In this test, the Chimera produces noticeably sharper results than the Argus. The Chimera is able to resolve Group 5 Element 4 with relative ease, while the APNVG struggles to fully render that same element, stopping at around Group 5 Element 2 or 3 or so. Now, to be clear, this level of resolution is beyond what most human eyes will realistically perceive in normal use, but it is a pretty important indicator of optical performance, and it lines up with my other results in my video testing. Next, we'll look at distortion. The Argus actually produces a fairly flat image overall, but the Chimera's distortion performance is even better. On the Argus lenses, you can see a notable pincushion distortion on the chart, not to be confused with fisheye distortion, while the Chimera produces a flatter image with much less distortion. To push this further, I ran a dynamic test moving the camera around the eyepiece to see how the distortion chart behaves when you're outside of the ideal eye box. Both goggles again perform well, but the Chimera's image flatness stands out even more in movement. The distortion remains very controlled and consistent, which lines up with previous results that I've seen, especially in my RPO lens test videos. Now let's move on to some outdoor flare testing using the DJI Osmo action cameras. Both cameras were mounted to the right optical pods of the goggles, and there's a couple things worth mentioning here. First, like I said earlier, the Osmos tend to exaggerate certain artifacts, especially on panoramic systems. Both of these actually produce a fairly seam-free image in normal use, but the camera exaggerates that even more so than you would normally see. So the Chimera seam tolerance is actually noticeably more forgiving than the APNVG, and you can see that with the Osmos, with the Chimera having this narrower kind of gap between the lenses versus the Argus one. The next thing that we're actually looking at here is going to be the flaring. Both lenses show comparable flare behavior, but in my experience, the Argus lenses produce more dramatic veiling glare and larger flare artifacts than the RPOs on the Chimera. Now I want to get into what I consider some more important comparisons, which is going to be shear, eye relief, and the collimation. So the collimation will affect how the image is sheer. Because the Chimera is easier to collimate and because the rear lenses are much closer fused together, the shearing is far less dramatic. With any panoramic night vision device, you're going to have some shear. That's just the nature of using conventional optics. However, the RPOs handle it much better. There's less ghosting, and overall, the image feels more cohesive across the entire panoramic image. At longer distances, these differences between the goggles will actually be less noticeable, but I intentionally performed this test at close range to highlight this effect, and this is important because panoramic night vision is often used in CQB environments where these effects are much more apparent. And finally, we'll get to probably the largest and most obvious optical advantage of the Chimera, and that's going to be the eye relief. And the difference here is massive compared to the APNVG and most legacy panoramic systems that I've tried. As I move the camera incrementally further away from the eyepiece, you can see why Nocturn selected these lenses for this design. The APNVG begins to vignette around 20 millimeters, whereas the Chimera maintains a wider field of view with significantly less vignetting even past that distance. In practical terms, this actually matters a lot. If you're using a panoramic system, you generally want to get the most field of view as possible, especially if you're running things like ballistic eyewear, gas masks, stuff in front of your face. The Chimera just becomes a much more usable system because you get more image in a realistic setup. And for applications where eye relief matters, which to be honest is going to be most of them, the Chimera is the clear winner, maintaining that advantage throughout pretty much every distance that the camera is at relative to the goggle itself. So there you go, guys. That was the lab results. And as you can see, the Chimera does provide a lot of key optical benefits over the existing panoramic design. But that out of the way, we're actually going to go out to the real world and compare a mono, which will represent as well a bino, because with a mono and a bino, you pretty much get the same field of view, and the panoramic Chimera to see how big of an advantage in various scenarios that having that 100 degrees field of view gives you over the standard 40. So let's go out there in the cold and have a look. So let's get on location for a few tests. These comparisons are not to compare the image quality of the NVGs, we did that in our previous tests, but to see the FOV advantages of a pano versus a bino. We're going to be shooting the traditional 40-degree field of view bino with our Sony setup, and our panos with the combined action camera setup. You may notice that the mono is slightly clearer due to it using a full-frame professional mirrorless camera versus these small action cameras. However, from our previous tests, you can see that the panos are similar in clarity to the bino. So keep that in mind as you view these comparisons in full 4K resolution. Now, unlike many drivers in your favorite populated area, we think peripheral vision is going to be pretty key to operating a motor vehicle, and this is where panos excel. This makes perfect sense because the original design intent behind panoramic goggles was for pilots to be able to see more in the sky with the Anvis 10. For these scenes, I feel commentary isn't even needed. If you're going to be in a car and you're driving around and you need to use nods to do it, there's really no other option that's better than a panoramic goggle. It just allows you to see far more of the roads. Any obstacles or anything in your way will be much more visible with Panos versus the toilet paper tube experience that you get with a traditional 40-degree setup. Now on this site at a park, we decided to go through this tunnel, which is about as close as you can get in an outdoor environment to CQB. Most people don't want to use panoramic goggles outdoors because of the weight, and in larger environments, it is easier to turn your head and you have more room to get that field of view. However, even outdoors, panos have a clear advantage. One use case I'm parroting is surveillance. If you had to pull sentry on a position at night, let's say you're on Overwatch duty, panos allow you to do that with less people than having guys equipped with binos. You can probably have 2 guys in a building to see pretty much the entire surroundings with panos versus needing 4 or more with a binocular setup. So depending on your use cases, panos can add a lot of efficiency to any group-based night vision activities. In terms of subjects entering the frame of image, panos offer a huge advantage. Obviously, with that wide field of view, you're going to see more of the image, and things will enter the frame a lot faster than they would with a traditional bino and mono setup. Very obvious to see with those extra tubes, you can see me enter the frame a lot faster than you would see with a bino device. You can imagine applying this to any outdoor situation, just allows for earlier detection of things that you may need to address. Now here's where panoramic night vision really shines, and this is going to be where you see most photos of operators using them, indoors and CQB environments. Indoors, you have far less room to maneuver, and there's going to be a lot of doors, hallways, and complex geometry to resolve. In this freeze frame, where we take the panos versus the bino, and we take this corner over here, you can see with the pano, not only am I seeing the corner of the room faster with my peripheral vision, but I also see the other door across the room where I normally would not see that with binocular night vision goggles. In this situation, I have one of my coworkers with an airsoft gun down the hall to represent some sort of opposing force, and I'm standing in the corner of our studio with the panos and the bino. And as you can see, I would normally have to turn my head to see the door and the hallway with the binos if I'm overlooking this room, whereas with the panos, I'm able to see the entirety of the room, no issue, and also see him moving around, no issue at all. So room clearing, doing stuff inside, panos are going to have a massive advantage. Now, if you've watched my boom slaying video in the past, you know that stairwells can be difficult areas to resolve because they have a lot of complex geometry and they tend to be in confined spaces. And here is also where panoramic goggles shine. By turning your head, you can actually get a bit more vertical FOV with the pano as well. Doing so in small areas with panos versus binos in a confined area like a stairwell just gives you a huge field of view advantage. Now you can cover the entirety of this stairwell with one person instead of needing multiple people and having to swivel your head back and forth between different subject matter. Overall, I feel like panos address the largest problem with night vision, which is going to be field of view, and in most scenarios, they're going to be a massive upgrade over standard 40-degree binoculars or monos. So those are the real-world tests compared to a mono, and as you can plainly see, having peripheral vision allows you to see quite literally more than what you would normally see with a bino or a mono setup. So, capabilities aside, let's go into some helmet accessory and setup recommendations for this guy. Over here, on my helmet, I have a Cadex mount, and it's going to be mounted onto a ballistic Team Wendy helmet. A lot of you guys have been asking about the cover. This cover is done by our friends at Paros Design. They're another Toronto-based company. They do great work. Go check them out for all of your nylon needs. I'm using a Cadex mount because it offers a huge range of adjustment for this goggle. The Cadex allows you to actually adjust the height with the adjustable backplate in the rear so you can get the optimal position for your goggle. In the rear here, I'm running a standard cold weather battery pack. The battery pack is not going to be enough weight for most goggles, especially not for a goggle as large as a panoramic goggle. So we do recommend adding additional weight onto your rear so that way you can have it perfectly balanced. As you can see, this is really, really nicely balanced right now. Our recommended way to do that is with our Cold Harbor multi-curve lead weight plates. These go behind your battery pack. They can be contoured to whatever shape, whatever battery pack you're using. So that way it's really low profile. And honestly, most people can't even notice it's there. Ear Pro is also going to be important. It provides a good amount of clamping pressure to your head. So that way when you put your helmet on, you have additional pressure on the side, keeping the nod nice and stable. And like I said, for a goggle that's going to be a bit larger, that is something you want to consider as well. So is the Nocturn Industries Chimera going to be the goggle for you? And honestly, this is going to be a dream goggle for many people, including myself. When I first started working here, I never thought I would get the chance to actually see these in person. and get to handle so many different types of goggles. And after handling so many, the Chimera definitely tops the list in terms of the coolest and most capable night vision goggles out there. You get that amazing 100 degrees field of view, allowing you to see what's previously unseen. It articulates, obviously, for nice stowage. Really, really great optical package made of fantastic materials, and honestly just very well designed from an assembly point of view. So it's pretty much the dream goggle for most people out there. But what's going to stop you from getting it? It's honestly going to be the price. Now, there's no such thing as cheap panos out there in the market. That'd be like saying you can get a cheap AP watch. It just doesn't exist. But if your unit or yourself can afford it, this goggle represents a lot of capabilities for any user out there. For agencies out there with existing binos or mono devices, and you want to upgrade to the Chimera, chances are your old devices may still have very usable intensifiers in them. We do offer retrofitting services, so send us a message or an email and we can take your old devices and rehouse them into a top-tier housing such as this one. So thanks for watching, everybody. That was a doozy of a video. Pretty difficult to film with the Chimera. I've never filmed through panoramic goggles before, so it was a learning process for me, and I hope it was for you guys as well. The Nocturn Industries Chimera can be found on our website right now. It is selling out very fast, so be sure to get one with the tubes of your choice, of course, if you can afford it. Thanks for watching, and we will see you on the next one. These are so big, so big, so big. But before you buy the Chimera, make sure you put a down payment on a house and get a car and potentially a girlfriend too. So, you know.